Hi, my name is Tarrant and welcome to a British Audiophile. About a week ago I posted a video about my top 5 inexpensive hi-fi tweaks, and number 1 on that list was replacing the generic freebie power cords that you get given to you with your equipment for something a little bit more substantial. Now this video is about walking people through the steps in what's involved in terms of putting together one of those power cords, and it's not as complicated as people may think. Disclaimer, you need to have the level of comfort with electrical equipment and wiring that you need in terms of replacing a mains plug, but not an awful lot more than that. The solution that I'm proposing doesn't involve soldering. So if you watch that video and you are sitting on the fence with regards to having a go at building your own power cords, this perhaps may be for you. The reason I'm picking this as a particular subject is that buying power cords are pretty expensive. Start off at around £100–150 here in the UK and go up to quite crazy prices. And you can build your own, certainly here in the UK, using good quality shielded cables with thick conductors and heavy insulation and generic plugs, which I think is all you need if you're getting started in doing this kind of stuff, for as little as £15–20. So let's get started. Now you can see between these 3 cables that the top cable here is the generic freebie cable. The next one down is the lap cable, which has this silver finish. It's actually a tinned copper braid that you can see there, and the Belden cable. And immediately you can see how much more substantial the lap cable is from the generic cable in terms of its construction, and it's a very similar story with the Belden cable. Between the Belden cable and the lap cable, there's not a huge amount of difference. They both retail for about £7 a metre. They both have 3 core conductors, which are 2mm in diameter. That's 14 gauge. They use PVC insulation. The only real difference is this braided shield that you can see on the lap cable with a clear PVC outside jacket, and a foil braid on the Belden, which has this black PVC outer jacket. Personally, I find the Belden a little easier to work with because of the shield and how it works. I'll explain that later. And the lap cable that I got supplied with had, instead of the blue and brown conductors, it just had black conductors labelled 1 and 2, and it's easier to identify conductors, I think, if they're different colours than it is looking for number 1 and 2 and remembering which one's live and which one's neutral. So from that perspective, I'll give the edge to the Belden, but there's not a huge amount of difference. You'd be quite happy with either of them, and they're quite easy to work with. So this is the Belden cable that we have here, and what I've done is I've cut back the black PVC insulation, and I'm not sure if it's clear here, but you can see this kind of brown furry stuff around the brown conductor, and that's a little bit of wool or cotton insulation, I think, which you also need to cut back. All these conductors are wrapped in a metal foil that also needs to be removed. And the most important thing when you're doing that is that you don't cut through any of the conductors themselves. So just a little bit of care. And then you want to get these conductors all to the right length. This short one here is the live one, that's the brown one. The blue one is neutral, and this green and yellow one is the earth wire. What you'll see here is this additional kind of tinned copper conductors, and that's your drain wire on this Belden cable. That connects through to the foil shield all the way along the length of this cable, and that's what you're effectively on this wall socket end. So we're looking at the wall socket end, the bit that you plug into your mains power strip or into the wall, and that needs to be connected to the earth wire. So that drain wire needs to be connected to it there, and that's effectively grounding your shield. So what I like to do also is place a little bit of electrical insulation tape around that earth connection and get that on nice and neatly. And what that does is it provides a little bit of extra protection. So if you're moving these cables around and for whatever reason that grounding becomes loose, you haven't got a chance of it shorting out by getting in contact with the neutral or the live. So I think that's a sensible thing to do, just wrap a little bit of electrical insulation tape around that drain wire, just for a little bit of peace of mind and added protection. So that's basically the plug end. I'll just wire up the plug and show you what that looks like. So I've wired up the plug here, and what you can see is this cable grip which holds the cable nice and securely in place. This brown wire is connected to the live terminal with a fuse next to it, and the blue wire is connected to the neutral. The green and yellow wire is connected to the earth terminal, along with the drain wire, which is also connected there. That's grounding your shield on this Belden cable. I'll show you the lap cable in a second. And essentially this is no different to wiring up a plug. The only real difference is that drain wire connecting to the earth. If you haven't wired up a plug before, I wouldn't urge you to do this by yourself the first time. Get someone who knows what they're doing, that you know who's wired up a plug essentially before, to do it with you. But it's relatively straightforward, as you can see. This is the lap cable that we have here, and essentially it's wired in exactly the same way. The only real difference is that instead of a foil shield, you have this braided shield which you have to twist together to form a conductor. It runs along here and to the earth terminal, exactly the same as it was with the Belden. I've wrapped this with black insulation tape, and as I said, that's in the unlikely event that this terminal coming loose, the braided shield, which is a conductor, could potentially create a short with this terminal or that terminal, and by wrapping it in insulation tape you eliminate that risk. I think being as neat and tidy is beneficial when you're doing these things, so keep the conductors as short as they need to be without putting any undue strain on them. Make sure there isn't any exposed copper, so cut the insulation back as far as you need to, but no further. And one thing I will point out, that this lap cable that I got from MCRU, which is Mains Cables R Us, is different to the one that they showed on their website. The one on the website shows the conductors in different colour. These came with live and neutral, both conductors in black, one labelled 1, one labelled 2. I think it'd be nicer if they were in different colours. It just makes it easier to know which one you're working with, whether you're working with the live or the neutral, rather than trying to remember which one's 1 and which one's 2. But it's no big deal, you just have to make sure that you connect it in the right polarity at both ends. We're back to the Belden cable, and this is the other end of the connection. This is the end that connects to your equipment via an IEC connector. Now, what you need to do is, again, peel back the black PVC outer jacket, cut back on this Belden cable the cotton or whatever it is, wool insulator. That you can see the kind of brown fuzzy stuff just basically poking out a little bit there. Cut back the metal shield, and I've changed my view on this really based on feedback I got from my last video. I used to ground the shield at both ends. Now, there's a couple of schools of thought on this. One school of thought is that by grounding the cable at both ends, that basically means that you take the drain wire and connect it at this end, that the shielding is more effective. The problem is that it can also create ground loop problems. Ground loop problems is where you've got shield connected in more than one place and there's a difference in potential. There's a potential difference, I should say, between one point and the other. That basically will cause a current to flow in the shield, which will be audible as a hum, and in worst cases will be audible as a form of distortion. So I think the benefits of grounding at both ends are debatable at best, but the downsides are probably more significant. So I would change my view and I would actually ground the cable just at the mains plug end and leave the ground open at this end. I checked with MCRU and that's what they advised as well, and a bunch of other people. So like I said, I've changed my view on this. So once you've got these conductors exposed and to the right length, you're ready to connect it to your IEC plug. So I'll show you that next. I like these Martin Kaiser IEC plugs for a few reasons. I've just popped the pins out here. A little tip for you: if you're trying to wire up these plugs with these thicker, stiffer cables, just slide the pins out. They slide out really easily and they slide back in. It's much easier to work with them that way than trying to clamp these cables down with the pins in situ. And the reason I like these Martin Kaiser plugs are they're inexpensive. There's no soldering involved. I think soldering will put some people off potentially, and they're really clearly labeled. I don't know if it comes through here, but you can see the live, the neutral, and this kind of upside down tree arrangement is the earth connection. So it's really easy to see what connects to where, and these just slot straight back in. They slide in nice and neatly, and once they're back in, you just put the cable cable grip on and the top cover on, and away you go. I'll just show you the lap cable as well, and it's exactly the same. There's no grounding of the shield going into the central pin, just the earth wire connecting in here, and it wires up in exactly the same way. If you get this version of the lap cable that has two black conductors for the live and neutral labeled 1 and 2, just make sure you make a note of what is live and what is neutral. If you're as forgetful as I am, maybe write it down on a scrap of paper. But yeah, it wires up essentially in exactly the same way. Hopefully that wasn't too painful. Those of you who are just perhaps curious or sitting on the fence with regards to constructing your own shielded mains leads may be encouraged to give it a go. For me, spending £15–20 to get something substantially better than the generic free stuff, especially when it only takes about 20 minutes of your time, is worthwhile, and hopefully it is for you as well. A little disclaimer: I'd just like to reiterate, if you're not entirely comfortable wiring a mains plug, or you see anything in that video that you're not sure about, I'd encourage you not to give it a go. I don't want to be responsible for people blowing up their equipment. If you've got a family member or a friend who can help you with that, perhaps maybe get them to do it for you. I'd just like to say thank you to my 9,000 subscribers out there. It's amazing that this channel's grown as far as it has and as quickly as it has, and to the tens of thousands of people who watch these videos and participate in the comments section. I do try and respond to everyone in that comment section, but it is becoming more and more difficult as this channel is getting more and more popular. But I'm just overwhelmingly grateful to the people out there who support this channel. So if you like this video, please hit that like button. If you like my attitude to hi-fi and the way I approach it, please consider subscribing to this channel if you haven't done so already. But for today, for now, a British audiophile signing off.